In previous lecture I discussed planar graph. If a graph we can draw in a plane without crossing of edges is called as planar graph. Then region, there are different type of region. One is bounded region, another is unbounded region. The regions that are inside the graph that are called as bounded region, and the region that is outside of the graph that is called as unbounded region. So a region is surrounded by the edges. Then Euler theorem, R plus B equals to E plus 2. R is region, B is vertices, E is number of edges. Then corollary 1, if G is a connected planar simple graph with E edges, B vertices and B is greater than equals to 3, then E should be less than equals to 3B minus 6. And corollary 2, E is edges, V is vertices, V greater than equals to 3 and no circuit of length 3. If there are no circuit of length 3, then E can be less than equals to 2B minus 4. Next I will discuss Kuratowski's theorem. So we have seen that K33 and K5 are non-planar through examples. K33 is bipartite graph and K5 is a complete graph having 5 vertices. So clearly a graph is not planar if it contains either of the two graphs as a subgraph. If a graph contains a subgraph K33 or K5, that is non-planar. So in all non-planar graph there can be subgraph of K33 or K5. We can obtain these two subgraph by doing some formatted operation. This formatted operation called as elementary subdivision. What is elementary subdivision? If we have edges UV, let this is edge UV, what we can do, we can remove this edge UV, then we can add another vertex, let W, and we can add a edge U to W, W to V. So this operation called as elementary subdivision. If by elementary subdivision we are getting K33 or K5, then that graph is non-planar. If we have two graphs G1, G2, G1 contains set of vertices B1 and set of edges E1, G2 contains set of vertices B2 and set of edges E2, then both graph G1 and G2 called homomorphic if they can be obtained from the same graph by sequence of elementary subdivision. Let's see one example of homomorphic. We have three graphs G1, G2, G3. Now example 7, so that the graphs G1, G2, G3 displayed in figure are all homomorphic. So by elementary subdivision we can obtain G2, G3 from G1. Just we need to check whether we can obtain or not by elementary subdivision. Now G1 can be obtained from G1 itself. So G1 is homomorphic to G1. Next check G2. In G1 there is a edge A to C. So what we can do, we can remove this edge A to C. We can add another vertex F. Then we can connect A to F, F to C. So there are two edges A to F, F to C rather than AC. Then there is a edge B to C that we can remove. We can add another vertex, let G. We can connect B to G and C to G. Next again we can remove B to G and we can add another vertex H and connect B to H, G to H, B to H, H to G, G to C. Rest all are same. So G2 can obtain from G1 by doing elementary subdivision. In the same way let's check G3. So in G1 there is a edge B to C and B to E. Rest all are same, just there is changes between B to C and B to E. What we can do, we can remove B to C edge and we can add a vertex G, then connect B to G, C to G. Again remove B to G and add a vertex I, then connect B to I, I to G. Okay. Next B to E. So remove B to E, then add a vertex K, connect B to K, K to E. Next again remove K to E and add a vertex J, connect K to J, J to E. So we got B to I to G, G to C and B to K, K to J, J to E in place of B to C and B to E. So by elementary subdivision we are getting G3. Hence G1, G2, G3 are homomorphic. We can obtain G2, G3 from G1 by doing elementary subdivision. Next theorem 2, a graph is non-planar if and only if it contains a subgraph homomorphic to K33 or K5. A bipartite graph having 3 vertices in one group and 3 vertices in another group, or K5, it's a complete graph having 5 vertices, then it is non-planar. Let's see one example based on theorem 2. Example 8. Determine whether the graph G shown in figure is planar. We have two graphs G and H. H is subgraph of G, and we have K5. K5 is a complete graph having 5 vertices. G, H, K5. So from G, if we are removing B to J, J to C, then C to H, H to G, and I to K, K to G, then we will get H. By removing some edges, we are getting H. So H is a subgraph of G. So the graph H obtained by deleting the vertex H, J, K and all the edges incident on this. Now this is K5, this is H. You can see that H is homomorphic to K5. This CG edge we can remove and we can add all these vertex and connect. So H can be obtained by doing elementary subdivision in K5. So H and K5 are homomorphic. So we found H is homomorphic to K5 as we can obtain this H by doing sequence of elementary subdivision on CG edge. So we can remove this CG edge, then we can add the vertex D, then again we can remove and we can add the vertex E and F. Hence graph G is non-planar. So G is a graph, it have a subgraph which is homomorphic to K5. Hence G is non-planar. So by removing some edge we can get the subgraph, and subgraph is homomorphic to K5. So for any graph, if its subgraph is homomorphic to K5 or K33, then it's non-planar. In next lecture, I will discuss some more examples of planar graph. If today's lecture is helpful for you, please like, share and subscribe. Thank you.